All right, good morning. So as you probably saw on Classroom, I said there's a couple different ways that we can do limiting reactant questions. The whole goal of a limiting reactant question is to figure out which of the two reactants you are going to run out of first. Okay, and there are two ways to do that. So in this first video, I'm going to show you the way that requires a little less thinking, but requires a little bit more work. And then in the second video, I'll do the one that requires a little bit less work, but a little bit more thinking. Okay, so the first thing we're going to do is we're going to do two different three-step stoichiometry problems, or two different dimensional analysis problems that have 3 steps each. Okay, so the question says we have 10 grams of Al2SO3 and it's reacted with 10 grams of NaOH. The first way that we can figure this out is we can calculate, or we can take both reactants to the same product to see which one will produce the most product and which will produce the least. Whichever one produces the least amount of product is our limiting reactant. So that's what we're going to do. The first thing we need to do is we need to balance this equation. That's going to help us get our coefficients that we're going to use in our mole to mole ratio here. Okay, so I'm totally balanced with the coefficients of 1, 6, 3, and 2. Okay. The other thing that you're going to want to do early on, and I've already done it, so I'll just share it with you, is you're going to want to find the molar masses of all these things. Just because it's going to speed up the process if you know what all of them already are. So like I said, I'm going to do two calculations. I'm going to take this reactant to one of the products, and I'm going to take this reactant to one of the products. But it has to be the same product. So I'm just going to arbitrarily, for no reason at all, I'm going to choose the second one, the ALOH3, and I'm going to take them both there. Okay. So for calculation 1, this is going to be my A, and I'm going to be calculating to react to product B. And then for number 2, this will be my A, and this will be my B. Okay, so if you're looking at your molar roadmap, I'm talking about this is where I'm starting and where I'm going. For the second calculation, this is where I'm starting, where I'm going. So here we go. So I have 10.0 grams of Al2SO3. I need to get all the way to grams of B. So it's going to be 3 steps. So I'm going to go ahead and flash up the molar roadmap, just that way you're on the same page of where we're going. First step, so I'm going to take it, I'm going to divide by the molar mass in order to get to moles. So I have 294.3 grams of Al2SO3 for every 1 mole of Al2SO3. Okay, grams are going to go away. Boom. Second step is I'm going to use the mole ratio. I'm trying to go from here to there, so the mole ratio looks like it's 1 to 2. So I'm going to say for every 1 mole of Al2SO3, there are 2 moles of ALOH3. And that's going to make moles of Al2SO3 go away. And then finally, I'm going to use the molar mass there to get to grams of ALOH3. So for every 1 mole of ALOH3, there are 78.0 grams of ALOH3. And moles go away. So when I do this, I find that if all 10.0 grams of Al2SO3 is used up, so if all of this were to be used up, I could make a grand total of 5.30 grams of ALOH3. Okay, so if all of this were used up, I could make that much ALOH3. So now I'm going to go through and I'm going to do the exact same process, but with the other reactant. Okay, so for this second calculation, what I show is that if all 10.0 grams of NaOH were to react, I could end up with 6.5 grams of ALOH3. Now this is where you have to do just a little bit of thinking. You say, okay, Well, which one produces less? Because whichever one produces less, that's the one I'm going to run out of first. So in this question, because I can only produce 5.3 grams of AlOH3 in the first one, but I could produce 6.5 in the second, that means that I will run out of the first one first. So the Al2SO33 is my limiting reactant, and it is what I'm going to have to use for every calculation from here on out.